In this video, we're going over all the key ideas in our geometry unit. So one of the first things we talked about is the difference between supplementary angles and complementary angles. So complementary angles, they sum up to 90 degrees, and supplementary angles sum up to 180 degrees. We talked about opposite angle theorem. And this theorem states that if you have two lines which intersect, the angles which are opposite to one another will be congruent. Straight angle theorem states that if you have a set of angles which form a straight line, the sum of those angles will be 180 degrees. I want to mention that I wrote the short form or the acronyms for the specific theorems that we've used in this unit, but on a test or a quiz, I want you to write out, for example, opposite angle theorem first. The first time you use that theorem, just write it out in its entirety. And the second time you use it, you can use a shortcut. Okay, so for example, the second or third or fourth time on the test or quiz you use the opposite angle theorem, you can just write OAT instead. Because now I know you know that OAT stands for opposite angle theorem. The reason why I don't want you just writing OAT right off the bat is because sometimes it might stand for something else. So for example, SAT could stand for supplementary angle theorem, which is entirely different from straight angle theorem. So I want you to write it out first, its entirety, without any abbreviations, and then if you plan on using the same theorem again later on, then sure, go ahead, and then I'll know what you mean. Okay, so we talked about opposite angle theorem, straight angle theorem, and now we talk about parallel lines theorem. This is something you should have did in grade 8, I would say. You have a pair of parallel lines that's cut by transversal, and then you can form patterns between pairs of angles. So there are pairs of angles which are corresponding angles, alternate angles, and co-interior angles. So if the pair of angles are corresponding angles, then they are congruent. If they're alternate angles, they are also congruent. Now if they're co-interior angles, then the angles are supplementary. Now I wrote F here because corresponding angles, you can highlight an F pattern with your transversal and your pair of parallel lines. And Z, same idea, you can have a Z pattern and C pattern for the co-interior angles. Okay, for the next theorem, we have the isosceles triangle theorem, which states that if you have an isosceles triangle, you'll have two sides which are of equal length, and the angles which are opposite the sides which are of equal length, those angles will be congruent. The equilateral triangle theorem states that if you have an equilateral triangle, all the interior angles will be 60 degrees. Triangle sum theorem, we use this many times, and this is once again something you should have learned in elementary school. That theorem states that if you have a triangle, the interior angles of a triangle add up to 180 degrees. Exterior angle theorem. The exterior angle theorem states that the exterior angle of a triangle is equal to the sum of the two remote interior angles. The quadrilateral sum theorem states that the interior angles of a quadrilateral add up to 360 degrees. And we had for all of these, we had proofs for these theorems. So you can go back to lessons and look at why they are. Like for example, quadrilateral sum theorem. Why did the interior angles of a quadrilateral add up to 360? Is because you can split a quadrilateral into two triangles, and you'll see that the interior angles do indeed add up to 360 degrees. We have the last two, I would argue, are the most important, because if you know the polygon angle sum theorem, which tells you how to find the sum of the interior angles of any polygon, you don't really need the triangle sum theorem or the quadrilateral sum theorem. But anyways, the polygon angle sum theorem, or some people call it the polygon interior angle sum theorem, that tells you that the sum of the interior angles is always equal to 180 degrees times n minus 2. 180 degrees n minus 360 degrees. And that is And what n is the number of sides. Let me try that again. So the sum is equal to 180 degrees and minus 360 degrees. So n is the number of sides. Now the reason why I said minus 2 by accident is because you can have a different variation of this. And that's why that's basically in factored form, but nonetheless you can use either version, and you can find the sum of the interior angles. And lastly, the exterior angle sum theorem states that the sum of the exterior angles of any polygon is 360 degrees, and we explain why that is the case as well. So those are the big ideas of this geometry unit, and using all these ideas you can solve for missing angles as long as you're able to solve an equation. And that goes back to the very beginning of the course. We started with the algebraic component, and once you've reached mastery, we learn to apply it in different settings. So in this unit, we're applying that skill set to help us solve for angles.